Welcome to our study in calculus. Today we look at differentiation of a composite function. So, whenever you have an expression or an equation, y is equal to 4 brackets 2x minus 3 to the power 8. So if your equation has an equation inside brackets and outside the brackets there's another power which raises the whole equation to that power, then what you have is a composite function and you need to apply the product rule to differentiate it. Note that this number in front of the bracket should always be a constant if you have to apply the product rule. Then if it's not, that rule needs to change to the quotient rule. So having said that, how do we work out our equation of this sort? We let the equation inside the brackets be equal to u. So let u be equal to the equation inside the brackets, which is 2x minus 3. After we let this one to be u, then our equation y now looks different because it can be expressed now in terms of u. After we do this, it now implies that y is now equal to 4u to the power 8. So we have this equation written in terms of u as well as y. So u is equal to 2x minus 3 and y is equal to 4u to the power 8. We then have to differentiate these two equations that we have here. So we first find our du dx, because we have x Welcome to our calculus study. Today we'll look at differentiation of a function or a composite function. So given a function y is equal to 4 brackets 2x minus 3 to the power 8, what you have here is an equation 2x minus 3 and then you have brackets having the power 8, meaning the entire equation is to the power 8. So you have this function inside, and then after you close up the brackets and you put the power, you have another function. So how do we get the derivative minus expanding our brackets? So we let u be equal to the equation inside the brackets. So we have 2x minus 3. Then after we do that, our equation y now looks like y is equal to 4. This now is our u, so it's 4u to the power 8. Now we have two equations, so we have to find the derivative of u and the derivative of y. So du dx is equal to the derivative of 2x is 2. So for the u we are done. Let's find the dy du. For this one, it's dy, and then you have a u there. So we have dy du is now equal to the derivative of this one. It's 4 times 8, which is 32 u, and then you have u 8 minus 1 to the power 7. Therefore, you have dy du dx. What you wanted to find is an equation dy dx, because you have this equation expressed in terms of x. So how do we get our dy dx? So now this means our dy dx is simply the product of these two derivatives you have found, du dx times dy du. So we substitute with what we've found. Our du dx is 2, so we have 2 times our dy du is 32u to the power 7. So then we have 2 times 32, which is 64 u to the power 7, and then what we have is 64. Now we can write what our u is from the beginning, which is 2x minus 3. So you have 2x minus 3 to the power 7. So that's the derivative of y is equal to 4 2x minus 3 to the power 8. Then we come to our second equation. So again, we write our equation y in a much more friendly way for us to be able to use the differentiation formula. Y will become y is equal to 2, we open our brackets, t squared plus 3 to the power half. So then, again, what you have here, the coefficient is a constant and you have an equation, then you have a power outside the brackets. So again here, you let u be equal to the equation inside the brackets, which is t squared plus 3. Then y now looks like this. It's 2u to the power half. We get the derivative of u, then we get the derivative of y. So du dt is equal to the derivative of t squared is 2t, derivative of 3 is 0, so we have 2t as our derivative. Then we find our dy du. So dy du is equal to, is the coefficient multiplying the power, so we have 2 times half u, then the power reduces by 1, so we have half minus 1, which is equal to, this is 1, 2 into there, it's 1. We just have a 1 left here, meaning what we have here is u half minus 1 is negative 1 over 2. So we have our du dt, dy du, implying that our dy dt, because our equation has to find, we have to find dy dt, is equal to, we multiply du dt times dy du. Then we substitute what we found. Our du dt is 2t times our dy du is u to the power minus 1 over 2. So then we have 2t times, the negative power simply means there we can have 1 over u to the power half, implying that our final answer now for dy dt is equal to 2t over, our u was 2t, was t squared plus 3, the power half is as good as square root. So we have the derivative in that equation as well. Finally, we have our final equation. So we have y is equal to, rewriting it also in a much more differentiable way using our differentiation formula, we're going to have 2. What you have here is this equation to the power 1. We push it up, it becomes negative power, so we have x to the power 3 minus 3x minus 4 to the power negative 1. Again, you let your u be the equation in the brackets, so u is equal to x to the power 3 minus 3x minus 4. Then your y now looks like this, 2u to the power minus 1. We differentiate our u, differentiate our y. So our du dx is equal to, the derivative of x to the power 3 is 3x squared minus derivative of 3x is just 3. Then we find our dy du, which is equal to 2 times negative 1 u minus 1, which is negative 2u minus 2. So now we multiply the two answers that we have to give us our dy dx to be equal to du dx times dy du. So this is equal to our dy, our du dx is 3x squared minus 3 times our dy/du is minus 2 over u squared. So negative 2 is multiplying everything here if we had to make this one over 1. So negative 2 times 3x squared will give us, or we can just have it negative 2, then we have what's in the brackets, 3x squared minus 3 brackets over our u squared. What our u is this equation here, so we write it as it is, x to the power 3 minus 3x minus 4 to the power 2. Then you would have found the derivative of that equation using the product rule. Thank you.